Okay, in this video I'll work some stoichiometry problems. Stoichiometry is a branch of chemistry that deals with the quantity of reactants versus products in a chemical reaction. So for example, if given a certain amount of reactant, we'll be able to calculate how much product can be produced. Or given a certain amount of product that we want to produce, we can calculate how much reactant we need to start with. The one thing that's really important to start a stoichiometry problem is to always make sure you start with a balanced equation. So before I even read the question on this first problem, let's look at the equation. Here we have aluminum reacting with oxygen to make aluminum oxide. If I look at my aluminum oxide, I see that I have 2 aluminums and 3 oxygen on the product side. So I need to balance that on the reactant side. To even out the number of oxygen, to make that an even number, I'm going to try doubling my products. That gives me 6 oxygen on my product side, so I need to change this coefficient for oxygen to 3. Now looking at the aluminum, I see that I have 4 aluminum on the product side, so jumping over here to the reactant side, I need to change this coefficient to a 4. Now that I have a balanced equation, I can actually read my question and see what information I'm given and what information I'm asked to calculate. So number 1 says, how many moles of aluminum are needed to form 2.3 moles of aluminum oxide? Whenever I work these problems, I start off by writing down what I am given out to the side, and then also make a note of what I'm being asked to calculate. So I'm given 2.3 moles of aluminum oxide, and I need to calculate how many moles of aluminum is needed to make that amount of product. To do these problems, we're going to use dimensional analysis. So like you've done before, set up a dimensional analysis structure. I always draw a horizontal line, and then as I go, I use vertical lines to separate my conversion factors. To go from moles of one substance to moles of another, I'm going to use these coefficients in the equation. For example, if I wanted to go from moles of aluminum to moles of oxygen, I could use these coefficients. Or if I want to go from moles of oxygen to moles of my product, aluminum oxide, I could use those coefficients. So let's see what I need to do here. If I have moles of aluminum oxide up top, I need to be able to cancel my units with moles of aluminum oxide down below. My goal is to get to my moles of aluminum. So I'm going to go from moles of aluminum oxide to moles of aluminum up above. The numbers that I'm going to write in here come from my balanced equation. 2 moles of aluminum oxide are produced for every 4 moles of aluminum that you start off with. So I'm going to associate the 2 with moles of aluminum oxide and a 4 with moles of aluminum. So I've canceled out these units. I'm at the units that I'm looking for. I'm done setting up my structure. I can start doing the math. Remember to multiply all of your numerators and then divide by the denominator. Or in other words, multiply any numbers at the top and then divide by the numbers down below. For example, 2.3 times 4 equals 9.2 divided by 2 is going to get me an answer of 4.6 moles of aluminum. So in this problem, given 2.3 moles of aluminum oxide, if I want to produce that amount of product, I need to start with 4.6 moles of aluminum. Let's go ahead and work the next problem because it's the same balanced equation, same aluminum reacting with oxygen to produce aluminum oxide. But this time I'm told that I need to start off with 17.2 moles of oxygen and see how much aluminum oxide I can form. Once again, off to the side, I always start off by noting what I'm given and making sure I realize what units I'm working towards. Okay, start your dimensional analysis with the number that you are given. For example, I'm going to start with 17.2 moles of oxygen. Draw my horizontal line and my vertical line. And now I need to think, what unit am I trying to get to? I'm trying to get to moles of aluminum oxide. To be able to do that, I need to be able to cancel out moles of oxygen. Put moles of oxygen down below. I need to be able to get to moles of aluminum oxide. The numbers that go in these blanks come from my balanced equation. There's a 3 associated with the moles of oxygen. There's a 2 associated with the moles of aluminum oxide. My units cancel that are on the top and bottom. And I'm already at the unit that I'm trying to solve for, so I can stop with my dimensional analysis. If I multiply the top, I get 34.4. Divide by the bottom with 3. And that gets me to my answer of 11.5 with the units moles of aluminum oxide. That's my final answer for question number 2. Now, for some of you using a calculator, you won't need to write down this step. This is just a little reminder that to solve these dimensional analysis problems, once you have them set up, you multiply all of the top numbers and then you'll divide by the bottom numbers.